Hello, everyone. I'm having some technical difficulties on my computer here, trying to get into the meeting. Sorry. I hope you're all with me. My name is Nathan, and this is a webinar about whole home backup featuring the Sol-Ark 15K and SimpliPhi batteries. I'm having some technical difficulties here, and I'm trying to work through them. So apologize for the late start. So today we're going to be talking about whole home backup featuring the Sol-Ark 15K and SimpliPhi batteries. My name is Nathan Heston. I'm a energy solutions trainer here at Briggs & Stratton. We're going to be talking about the Sol-Ark 15K and how to do whole home backup. We'll talk about generator integration, our latest battery offerings, and this is a NABCEP certified talk. So if you're here for those NABCEP credits, please stay through the end. I'll provide my email, ask you to email me, and I'll send your certificate via email. As we get started, I want to point out that you should have a Q&A you should have a Q&A option on your laptop. Unfortunately, I cannot see the Q&A at this time. But hopefully I'm able to work through those technical difficulties as we get started. So if you have questions throughout the talk, please go ahead and use the Q&A feature. Again, apologize for the late start here, having some computer issues, but let's go ahead and get started. I want to point out here at the very beginning, if you're not a new customer to Briggs & Stratton, so Briggs & Stratton has long made engines in the US. We're a 115-year-old company, long history of high quality manufacturing done in the United States. They acquired SimpliPhi Power about 3 years ago now. SimpliPhi Power is a battery manufacturer based in Oxnard, California, which is where those batteries on the right side of the screen have been made. And SimpliPhi Power has been making lithium iron phosphate batteries for home battery backup, off-grid applications since 2010. So I want to highlight that we are now one complete integrated energy solutions provider. Briggs & Stratton has long made generators for home backup and have moved into the battery market with their SimpliPhi battery purchase. So our latest battery offering is shown on the right side of the screen. That's a SimpliPhi 6.6 stackable battery. You can build stacks of that battery up to 3 tall, up to 6 stacks in parallel to get 120 kilowatt hours of backup. That's an outdoor rated battery. Temperature range charging from 14 degrees Fahrenheit all the way up to 120, I believe, Fahrenheit. Discharging range is even wider from 0 Fahrenheit all the way up to 140, I believe. So that's an outdoor rated battery. It can be wall mounted or floor mounted, and we'll talk about that a little bit. We, of course, still have other batteries. The batteries on the left side of the screen is our Phi battery. It's been powering homes and off-grid applications for years now. That's got a 10-year warranty with it. The Amplify battery made down in Oxnard, California is eligible for SCHIP. So is the Phi battery on the left. The Amplify battery and the SimpliPhi battery, 4.98 kilowatt hour battery there, can have a 15-year warranty with no limits. So no limits on cycles, number of cycles, no limits on throughput. So it's a true 15-year warranty backed by an American company. It's been around for 115 years. But what we're really encouraging our customers to do now is to utilize our new stackable battery. And that stackable battery, as I mentioned, is outdoor rated, and we're going to encourage you to pair that with a Sol-Ark 15K, which we feel is the strongest and most versatile inverter on the market with that 200 amps of pass-through. And so we're going to get into how that can be leveraged to create whole home backup. And we'll talk a little bit about what we mean by whole home backup. So I'm showing on the screen here are Boss 6 and Boss 12 cabinets. These are UL certified, 9540 certified, and 9540A safety tested cabinets. They're NEMA 3R rated outdoor. There's a temperature controlled fan on those cabinets. And we have these with options to integrate heaters if that's needed in your location. And we can also integrate an inverter into the top of that Boss 12 cabinet to have kind of an all-in-one plug-and-play option like is shown on the screen here. So this is what we're calling an access cabinet. We can do that with a Sol-Ark inverter, a Schneider inverter, etc. We unfortunately cannot put the Sol-Ark 15K inside the enclosure just because the 15K puts out a little bit more heat than we would want in an enclosure. But that's an outdoor rated, this Sol-Ark 15K is an outdoor rated inverter. So we recommend just putting that on the outside of the house if the space is needed. I want to point out as we get started, we'll talk about generators a little bit today, but I'm going to be talking about how to integrate generators with a backup solution. And one of the nice things about generators is that they have almost an unlimited runtime, unlimited fuel supply in the event of an outage. So as long as you've got a large fuel tank, like a large propane tank, or if you've got access to natural gas, these what you're seeing here on the left side are the air-cooled generators from Briggs & Stratton for home backup. And these are engineered with what we're calling NG Max, which allows, there's actually no D rating when you're running these things off of natural gas. So the 26K generator will truly give you 26K off natural gas, unlike many of our competitors where there's a D rating due to the lower energy density of natural gas compared to propane. I'm going to be talking a lot about the Sol-Ark 15K today and about Sol-Ark in general. So just like Briggs & Stratton, Sol-Ark is a US-based company, a Texas-based company. And they were founded in 2013 by some US veterans. They're a Texas-based company. They've been rolling out inverters since they launched their 8K inverter in 2018. And SimpliPhi batteries have been paired with Sol-Ark inverters since Sol-Ark first got started. And we found it's probably our most versatile inverter on the market. It pairs very well with our batteries. We have closed loop integrations with Sol-Ark. What makes it so great is it's kind of an all-in-one inverter. So it's got everything built into it. So you've got your charge controller built in, you've got your monitoring app, your communications platform built in. There's no external gateway. It's got your MPPTs, your charge controller. You've got your generator integration port built in. And you have seamless backup of 5 millisecond transfer time. It's NEMA 3R rated. It's NEM 3 VPP virtual power plant ready. And there's a lot of great things to say about the Sol-Ark inverters, particularly their software. So they've got a lot of experience getting things right, and these inverters just work and continue to work, and are very consistent. So we've got a line of options, package deals with the Sol-Ark inverters, including one with the 8K inverter, one with a 12K inverter, another one with the Sol-Ark 15K inverter, especially with our featuring our new batteries. We're going to be focusing in on the 15K inverter today. I've put this table together just to give you information about each of the inverter offerings that are coming from Sol-Ark. We also have high voltage batteries that will work with a 30 and 60 for 208 if you're looking for three-phase 208 or three-phase 480 in terms of the Sol-Ark 60K. So we've got integrations on the high voltage side as well through our commercial and industrial side. The 15K will point out some things. So it's capable of inverting 15 kilowatts of power. 12 kilowatts of that can be inverted directly from the batteries. The additional 3 would come from solar, or if you have more coming from solar, it could use less from the batteries, etc. But capable of producing 15 kilowatts from the DC side. So your solar and your batteries, DC solar and DC batteries. You can parallel up to 12 of these units. So if you have a very large installation, you can parallel 12 units to power it. You can do 3-phase, you can do single phase, you can do split phase, which we often think of as single phase here in the US, but that's where you have two 120s relative to a neutral. So you can also do 2-phase 208. So I actually run a 15K inverter in my shop that's running 2 phases of 208. So 2 phases of my 3-phase in the shop. So with 2 inverters, you can do unbalanced 3-phase. With 3 inverters, 6 inverters, 9 inverters, 12 inverters, you can do 3-phase balanced 208 in the Y configuration with the Sol-Ark inverters. It's got 200 amps of pass through, and this is the big game changer here compared to the 12K. So both the 8 and the 12K only have 63 amps of pass through, and so it's difficult to back up a common home even when it's a 100 amp service. Do a complete home with a Sol-Ark 12K, but with a 15K, having the ability to pass through 200 amps, having the ability to produce 12 kilowatts from the batteries to back that home up during an outage is a pretty big game changer. And I'll also point out that one of the reasons we really like the Sol-Arks as well is how easy it is to integrate generators. So with a 15K, you've got 19 kilowatts of continuous power that can come in. That's 80 amps AC that can come in through the generator port. You can bring in more power than that through the grid port. You can bring it up to 200 amps AC through the grid port if you use a transfer switch with a generator. And then on the DC side of things, you could bring in just under 20 kilowatts of DC solar. If you use the gen port for AC coupled solar, you can bring in 19 kilowatts of AC coupled solar on the AC side. And these are the AC and the DC solar are somewhat independent. The AC bus is the limitation on the AC side on the gen port, and then the DC bus is your limitation on the DC side. So you could bring in, let's say, 15 kilowatts of DC and couple in another 10 kilowatts of AC that you might already have on the roof for the 15K. So let's talk a little bit about what an ESS is here as we start. And now I do see the Q&A feature popping up on my computer. So no, it looks like I have the chat feature able. So unfortunately, I'm not able to see questions if you have them, but yes. So actually I am. So if you have questions, go ahead and put them in the Q&A as we run through this presentation. I'll try to answer them as we go. So an energy storage system normally with solar means a battery backup, right? Having batteries there to store the energy that's coming from the solar. And there are a number of reasons why you might want to do that. Typically, we size solar systems to produce more power than we need during the daytime. And historically, under NEM 2.0, you could send that excess power back to the grid and get compensated for that. Now, compensation rates, at least in California, have been greatly reduced. And so it's not net energy metering anymore here in California. It's kind of changed to a net billing system in which you get compensated very little from sending excess solar back to the grid. So if your solar is more than your loads during the day and you're not sending it back to the grid, you would need somewhere to store that energy. And that's where a high quality battery like the 6.6 battery or the 4.9s are here come into play. So you store up that extra solar energy that's generated during the daytime, and you use that at nighttime when you need that power. You can also integrate a generator with an inverter. At the heart of an ESS system is an inverter, and that manages multiple sources of power. And you can use multiple sources of power simultaneously. So for instance, if your home loads are consuming, let's say 10 kilowatts and you only have 7 kilowatts of solar coming in, the batteries are capable of supplementing that 7 kilowatts of solar and covering the full load so that you're not having to buy from the utility, which would typically be more expensive. So what exactly do we mean by whole home backup versus a partial home backup? So a typical system would be Historically, a typical system would be what you have on the left side of the screen, right? This partial home backup. And this might be a Sol-Ark 8K or a 12K inverter with that 63 amps of pass-through. So you would feed that inverter through a breaker in your main loads panel. And then if the grid were to go down, what would happen is that the inverter would isolate itself from that main panel. So it would open a relay inside the inverter to make sure we're not feeding any power back to that main panel and back up onto the grid where linemen might be working. So in a grid down situation, all of the loads that are in the main load panel are not backed up. On the other side, on the critical loads side, you would feed a sub panel out of the inverter, and all the loads that you've moved over into the critical loads panel would be backed up in a grid down situation. So you could feed that solar into the inverter, and you could feed a battery into the inverter. And as long as solar was more than the backed up loads, the battery would charge during the daytime. And then at nighttime during a grid outage, that battery would be discharging into those backed up loads. Well, this is not ideal for some, customers. It is, of course, more expensive to back up the whole home. But it's actually an easier installation. And so if you are backing up the entire house during a grid outage, the inverter will isolate itself from the grid. So you could have a fuse disconnect or a breaker disconnect here, 200 amps of pass through. But all of the power coming from the grid actually would pass through the inverter. And so now the inverter is backing up the entire main electrical panel of the house. So all the loads in the house. And we can talk about, there are some clever ways to do this. So if during a grid down situation, you don't want to run the pool pump or the spa heater, etc., you could run that off of a sub panel that's fed out of the smart loads port on the Sol-Ark or the Gen port. So you can use that as a smart loads port and dump some of those loads in a grid down situation. Again, we're bringing our solar into the Sol-Ark. If you do have AC coupled solar with microinverters, the Sol-Ark is capable of keeping those alive in a grid down event as long as you've got a battery to run that Sol-Ark off of. So this is whole home backup. The battery that we're going to be talking about the most today is our 6.6 battery. This is a wall mountable or floor mountable battery. It uses LFP, lithium iron phosphate battery chemistry, which is much safer in terms of a chemistry than some of the other products on the market, and that's very important. Also has more cycle life. So that's the other reason that we've always used LFP chemistry. Is just the most duration, and most other companies are moving towards that. I think last year was the first year that Tesla and Rivian produced more than half of their cars with LFP technology, and so that's where the market is going from a safety and lifetime standpoint. The 6.6 batteries, they're stackable batteries, so there are no wires. Except for that final run from the controller at the top. So the battery itself consists of a base unit, modules that are 6.65 kilowatt hours each, and then a controller at the top. Out of a single stack module, you can get 6.6 kilowatts of power. So that's a very high power output ratings. That's a C/1 rating. Typical batteries are C/2 or C/3, which means the fastest you can discharge them is 2 or 3 hours. This battery, you could discharge it in as little as 1 hour. So it's a very high power output battery. In stacks of 2, our controller limits us a little bit. We're looking at 10.6 kilowatts of power out of a 2 stack, and out of a 3 stack, we can get 14 kilowatts of power. Note earlier I mentioned that a Sol-Ark 15K is capable of inverting 12 kilowatts from a battery stack. So this battery is more than capable of providing the maximum amount of power that a Sol-Ark can pull from a battery bank. And then if you want more energy storage overall, these are essentially 20 kilowatt hour stacks. If you want more storage, you can parallel up to 6 stacks to get you 120 kilowatt hours of backup. Again, these are wall mountable, parallelable. So the mounting of this battery does have a rack, and that rack is there to prevent that battery from tipping over, but it is essentially invisible by the time you've completed The installation, it's hidden with side plates, etc. The installation itself goes very fast. The installation I'm doing here on just this training cart took about 7 minutes to fully assemble the entire battery. On a real job site, you're looking at probably 30 minutes once you get that wall mount set up, etc. But it's a very fast installation, given the rapid stack connectors that Briggs & Stratton has brought to market here. Let's talk a little bit about what a wiring diagram or a quick single line diagram would look like for a Sol-Ark 15K. So a very typical example here, we've got some DC coupled solar in the top left that's feeding in through a disconnect here, going into your Sol-Ark 15K. We've got our battery feeding in. You've got communication coming from that battery going to the Sol-Ark 15K. And then we also have our utility connection. So our utility connection, we're going to come through a service entrance rated 200 amp fused or breaker disconnect. That 200 amps would come into that Sol-Ark, and then all the loads of the house would be fed out of the load port, the 200 amp load port in the Sol-Ark 15K. So, sorry, my mouse is a bit touchy. So we can do this. We can also add more to this. So if we're in a location that has typically very long outages, like maybe somewhere in Florida or Louisiana, where you can get hurricanes that can take power out for a week, you might want to have a backup generator integrated as well. Another really nice thing about that Sol-Ark 15K is you can run off of solar and batteries unless your batteries get down too far, and then the inverter can start up the generator. That generator can then charge up the batteries, shut the generator off quickly so you're not using a lot of fuel, and then you'll run off those batteries again through that main loads panel. And so the Sol-Ark is capable of controlling that generator through a 2-wire start, and I'll talk about how to wire that a little bit later. So the generator port on the Sol-Ark 15K, so the Sol-Ark 15K has dual battery inputs on the left. The generator port, you can bring in up to 19.2 kilowatts of continuous AC power. Now that could be a generator with 2-wire start enabled. It could be AC coupled solar. So if you've already got maybe 15 kilowatts of AC coupled solar on the roof, just bring that in through the gen port. If you still want a generator and you have AC coupled solar, we can utilize a transfer switch and bring the generator in through the utility port. And don't worry, the Sol-Ark 15K is smart enough not to backfeed the generator. So if you do put that generator on a transfer switch and you've got AC coupled solar and you're worried about backfeeding it, the Sol-Ark 15K has got protections built in to realize when it's a generator providing power and prevent backfeeding the generator when you have that transfer switch installed. So here's that example where I'm showing you a generator connected to the grid port. So the gen port remains open. So if you've got AC coupled solar, you can bring that in through the gen port. Another nice reason you might want to use a transfer switch and bring the generator in through a transfer switch, you can still use a 2-wire start and you still run off the batteries until the batteries get low, is you could use the gen port as a smart loads port, and you can have up to 80 amps of AC 240 volt AC on a sub panel that might drop loads off based on battery percentage. So I think I used the example earlier about having a pool heater, a pool pump, or a spa pump, heaters, etc., that you might not want to power during a grid outage. Well, you can put them on the smart panel, a sub panel coming out of the gen port, and then just have that sub panel shut off anytime the batteries are not at pick a value, 90% state of charge. That's programmable in the Sol-Ark. So if you're running off batteries and there's not excess solar, you could drop those loads off. But you might want to keep those on if you've got plenty of excess solar and your batteries are topped off and just floating. You might want to keep those on. And so using the gen port as a smart loads port is a nice option. The downside to that, of course, is you do have to buy that transfer switch. But for a lot of customers who might already have a generator installed and a transfer switch installed, this does simplify the installation, and it leaves that gen port open, the 2-way gen port open for other uses. So some highlights of the Sol-Ark 15K is that you get effortless communication with our batteries. All of our batteries are vetted to communicate well with the Sol-Ark inverters. You can do an indoor and outdoor installation. A lot of customers will put the Sol-Ark 15K on the outside of the home just to free up wall space in the garage, etc. So it's a IP65 rated, just like our batteries, NEMA 3R enclosure. 12 kilowatts from batteries to load. So you got 12 kilowatts continuous. If you've got some solar, you can have 15 kilowatts of continuous power out of this inverter. You've got a surge of 24 kilowatts for up to 10 seconds. You can do 19 kilowatts of solar on the DC ports, 19 and a half on 3 independent MPPTs. You've got an additional 19.2 kilowatts of AC PV through the gen port if that port remains open. Big thing for me, that 200 amp pass through makes this easy to install. You've got a 100 amp breaker on the generator port. You'll want to, for continuous use, derate down to 80 amps continuous, but you've got 80 amps continuous on the gen port, and you've got automatic 2-wire starts of all of our Briggs & Stratton generators. And you can stack this unit up to 12. We've got a long history of success with these Sol-Ark inverters. So a truly great product here. I do want to make sure that when we are installing something like a Sol-Ark 15K, that we pay attention to how much battery capacity is there. And what's important here is to realize that the overall capacity of the batteries influences how much power capacity they have. So typically the SimpliPhi batteries have always had a C/2 rating. Our latest battery offering, which means that you can pull about half the power of a battery out per hour. So a C/2 rating would be half the power. So if I've got a 10 kilowatt hour battery bank, I could pull out about 5 kilowatts typically. With our newer battery, we've got higher power output. But for a 15K, we'd need a minimum of 3 6.6 batteries, so a single 3-module stack to run that properly. Want to point out the 2 options here with Sol-Ark 15K. So for a single stack of 3 batteries, you've got enough power to run this. Your backup duration, depending on how rapidly the customer is using power, what their loads are, will ultimately depend on, how quickly they're going to use that energy. So our common configurations, that we have installations which have 4 stacks with the single Sol-Ark inverter. Commonly, we're seeing customers install 1 or 2 stacks of batteries with a 15K inverter. It gives you an amount of backup time anywhere between 12 hours for a heavy user on the single stack to maybe 24 hours for an average user. 2 stacks can give you a couple of days of backup. Also, nice to point out that on a Sol-Ark 15K, you've got dual battery inputs. So if you actually have 2 stacks, you can run each of those 2 stacks and go directly into the 2 battery input ports on the Sol-Ark 15K. You can use 2 sets of 2-aught cabling that way. For a single stack, we still recommend using dual sets of battery cables. Dual sets of 1-aught is fine. Or if you're not putting the battery cables in conduit, then 4-aught, a single set of 4-aught would be fine. And Briggs & Stratton does make a combiner if you want to combine those battery inputs on the Sol-Ark 15K. So let's talk a little bit about multiple stacks. Let's suppose you wanted to do 4 stacks of batteries with a single inverter. Well, if you're going to do more than 2 stacks, you will need to use a combiner. And there are a number of different ways to use a combiner. So this kind of messy looking diagram I've made on the right side of the screen is done in a specific way, and I'll talk about that in a second. So the first thing is that when you are doing multiple stacks of batteries, you'll want to have each of the cable lengths be the same. So you want the cable lengths of each of the battery stacks to be the same length, and that makes sure that the inverter is kind of balancing the load equally among those 4 battery stacks. The combiner also should have overcurrent protection built into it. So if you've got multiple stacks, then you'll want to have overcurrent protection built in. That could be a fuse, that could be a breaker, and the controller itself already has digital overcurrent protection built in. So the different options here, I'm showing a Midnight 1000 amp combiner up here in the top left. This is a very common one. You'll see some breakers here on the sides. I think you can do up to 8 of these breakers on a single, maybe it's 10 breakers on a single Midnight 1000 amp combiner. This 1000 amp combiner is pretty big though. It's about 12 inches deep, 24 by 36. So it does take up a decent amount of wall space. One thing that customers are doing is integrating things like power distribution blocks for combiners, and that's a nice option for combining multiple stacks. It's not always required, but some jurisdictions require a DC switch between the battery bank and the inverter, and you can use these Rincon UL listed DC disconnects that are rated up to 1,000 volts. I caution you about using cheap disconnects that are rated to too low of a voltage. You'll want to make sure it's rated to a higher voltage. And Rincon makes a nice UL listed example for under $100. I'm showing also some Midnight combiner options. These, you can put dual breakers, DC breakers in these. But my favorite example is going to come up next. There's also a way to use these Class T fuses, but I'd like to show you this example. So this is a completely new product from Victron, the Danish company. So this is a Class T combiner. So what it does is allows you to use these Class T fuses. So you have individual overcurrent protection on each stack. And this thing retails for something around $170. So much cheaper option as a combiner, but really well made from Victron, which is makes great products. So what you can't see very well here is that the negative battery cables are attached to a 1,000 amp bus bar on the bottom, and then these units are stackable so that you'll put the inputs of the second on the outputs of the first, and so you can stack these. So if you want to do 6 stacks, 3 of these would give you a 1,000 amp combiner with individual overcurrent protection on each one of your battery inputs. So there's a space here between these, and so I've got each battery stack has an individual fuse on it, leading to that overall positive bus bar, 1,000 amps on the top, and the negative bus bar runs underneath on the bottom at 1,000 amps as well. You'll want to pull off opposite corners here, so you can pull a single cable off of this one at 4/0, another cable off this one at 4/0. The connections are sized to allow you to use 4/0. So this is a nice example, low-cost way. Russ asks, would our plan designer use your line drawing for our plan set? They very well could, Russ, and I will be sharing the presentation with all of you, so you'll get a PDF copy of this slide. And you can use our single line drawings if you would like to. And you can, of course, modify them as well. If you need help with single line drawings, if you need help with your plan sets, you can also reach out to our team. We have a series of application engineers here that are happy to help you as you're making that design of your system. So thank you for the question. So here's another example showing this with a couple of Boss 12s. So I'm showing an example of 2 Sol-Ark 15Ks paired. This will give you up to 400 amps of service. Remember, I said you can parallel to 12 of these 15Ks. I'm showing here, these are optimizers or rapid shutdowns on the panels. If you're doing rooftop mounted solar, you're required to have rapid shutdowns there. And what those do is there's a keep alive signal that gets sent from the rapid shutdown transmitter that keeps these devices closed unless that keep alive signal disappears. So if a fireman comes to site, hits the rapid shutdown button, that would trigger the keep alive signal to die, and then these would all open, which shuts all the solar panels down at the panel level to keep it safe. A lot of solar strings are 400 or 500 volt strings, and just with vinyl over the conductors there, and so that could melt in the case of a fire and could be very dangerous. And so code requires rapid shutdowns on rooftop mounted arrays. I'm showing this here. We've got a 1,000 amp combiner that's here. Briggs & Stratton also offers our own 1,000 amp combiner. We'll have more products on the way. You could also use, for these batteries, you're not required to have overcurrent protection on them. And so you could use a power distribution block to combine inside the wireway. Do keep in mind, if you are doing a wireway underneath the Sol-Ark 15K, those units are, the Sol-Ark 15K units are about 12 inches deep. So you'll want to get a deeper wireway. Do you sell or package the 400 amp AC fusible service disconnect combiner panel? No, I don't think that we do, Russ. The Victron unit that I'm showing above here, I did include a link for you. That's widely available, but there's a link here for this 1000 amp combiner that's here. And you could, of course, just use a couple of them to combine 4 stacks. With a Sol-Ark 15K, if you're combining 2 stacks, you can use the dual battery bus on the Sol-Ark as your combiner. So good question. I think we have a 1000 amp combiner that we sell, and we have 2000 amp combiners that we sell. And so those should be on our price list. You can talk to the applications engineers as you're designing your system for that. This is a nice example of, these are actually 2 12Ks here that are paralleled up. This is a nice example of just a custom metal battery cabinet here, holding 5 batteries, and it's a common choice of battery. And the other nice thing here, they're pulling, see how they're pulling the battery power off of opposite terminals. So the positive will be connected in the top left here, and the bottom right. And that's to balance the load on these batteries as much as possible. It's a good practice to do overall. Here are a couple of examples where we've got 7 12K inverters here in the top picture. It looks like maybe more, I can't see in the picture. We've got about 100 amps of 5 batteries. This looks like a Briggs & Stratton 2000 amp combiner here, and we've bussed these batteries together. So this is a nice example of a custom system. This is a native village of Eagle up in Alaska. Wolf Solar did this installation. The one here on the right side of the screen, I think, has 7 15Ks. 4 more are in this room that you can't see on the other side of the wall. And this has, I think, about 80 of the 5 batteries. So for very large systems, the 5 battery makes a very nice choice for combining for a large battery bank. Keep in mind, when you're doing paralleled inverters, you only want to have one bank, right? So you got to parallel your battery banks and then split out of that combiner to power each of your individual inverters. You would never connect one bank to one inverter and a second bank to a different inverter. We don't do that. All right, so a Sol-Ark 15K, I'm going to point out, sorry, trouble with this mouse right now. And the buttons aren't working for some reason. Okay, sorry. So on the DC side, we've got dual battery inputs on the Sol-Ark 15K. So you've got the 2 positives here, and these breakers are both on the single positive pole for the battery inputs. Then you've got the dual negative inputs on the batteries. So for 1 or 2 stacks of 6.6 batteries, you're good to go without a combiner. If you're paralleling units, you would use these communications ports here. The battery CAN bus will come out of a single one of the batteries in the bank. So it doesn't matter which battery, but you'll use one of the batteries to connect through the battery CAN bus here. All of the batteries would be daisy chained with the communications. I'll show an example of that in a minute. Here is the comms bar on the Sol-Ark 15K, and I'll break that out in a separate slide. These are your solar inputs. You have 3 independent MPPTs, 6 overall inputs. So keep in mind that when you're combining 1 and 2 with 3 and 4, you're paralleling these units. It's not important to have the same amount of current on each of those when you're paralleling them, but it is important to have the same number of panels, or at least an approximate same input voltage on your MPPTs. That'll allow the MPPT to function well when you're combining strings of solar. So you got 3 independent MPPTs, 6 overall solar inputs. The generator port is 80 amps continuous, 100 amp fused. And then your neutral bar and your ground bar down here at the bottom. Your load port is 200 amps here. This is a disconnect, not a breaker. So you do want to have a panel with an integrated 200 amp breaker on it. And then you've got a 200 amp input on the grid side as well that should be connected through a breaker. Can you make your mouse arrow larger so we can follow? sorry, Russ, I'm not sure how to do that. I'll try to just be slower with the movements of the mouse. And I'll do that for the next session. I had to switch computers here because my other computer was having some problems. We're looking at closed loop communications for SimpliPhi batteries here. So on the SimpliPhi batteries or our 4.9 batteries, the closed loop communications, there's two sets of ports. There's a device port, and then and these are labeled on the batteries. I'm showing a battery without stickers on it here, labeling them. But the device port is used to connect to the inverter. And then the battery CAN bus ports are used for daisy chaining. You never want to have a battery port that's open. So we go from the first battery to the second battery to the third battery to the fourth battery. Notice that the first battery and the last battery would have open ports. So we'll put a terminating resistor there, and that tells the CAN bus system that, hey, this is the last battery or the first battery in the chain. And then you can pull out of any of the batteries. It could pull out of this battery, the last battery, and go to the inverter. So you need one of the batteries connected to the inverter through the device port. And that would make that connection here on the comms board inside the Sol-Ark 15K. If you are integrating a generator, you would want to do that with pins 7 and 8 on the control board here. There are a number of things that you use these the control wires on the Sol-Ark for. A rapid shutdown is one of them. Another one is pin 7 and 8 to do the 2-wire start. So this is what lets the inverter start up and stop the generator to charge the batteries as needed. On a Briggs & Stratton generator or air-cooled generators, I'm showing the 26K and the 13K power protect units, you'd want to use pins 4 and 5. So this is pins 7 and 8 on the Sol-Ark are a normally open contact. It's a dry contactor. And so in the event that it wants the generator to start, it would close those contacts, and that would automatically start up that generator and then start charging those batteries after that signal is qualified. So here are the other ports on that on the comms board of the Sol-Ark 15K. Temperature sensors you're not going to use unless you're using older lead acid batteries, which are really a lot less common now. But if you have an existing install with lead acid batteries, you could use that temperature compensation sensor, and that would allow the Sol-Ark inverter to do a better job at getting your state of charge. CTs, even though a Sol-Ark 15K's got 200 amps of pass-through and all that power from the utilities coming through it, Sol-Ark still recommends that you use your CTs. So 3 and 4 would be leg 1, 5 and 6, leg 2. The auto start we just talked about, pins 7 and 8. Not using 9 and 10, but B and B is your e-stop button, and that's a normally open dry contactor. So if you short pins BB out, that will shut down the loads, that will shut down the entire inverter, and so that would for your rapid shutdown that would turn off. Pins 15 and 16, if you do use an AP Smart transmitter, you could actually power it off pins 15 and 16 for the rapid shutdown. You could always power your rapid shutdown signal transmitter off of one of the loads ports. And that's what we recommend for a brand like Tigo that needs more power than the 100 milliamp max out of pins 15 and 16. But AP Smart, you could power directly out of those two pins. You do need to have 6 inches of spacing between the gutter and the inverter that's above. That's a minimum. On the sides of the inverter, it's 2 inches on the sides, unless you've got another inverter directly next to it, and then it's 6 inches. So a real nice way to do the installation is with a wireway, and then you can put things like your power distribution blocks in there to do combining, etc. Or one of those Victron units would easily fit into one of these 12 by 12 wireways. Other things to keep in mind, up here in the top right, I'm showing, I think Practical Preppers sells this unit. It's got a template for your knockout. So this is really nice if you want to get your knockouts perfect in the wireway under the Sol-Ark 15K. So if you do a lot of installs, this would be a really nice thing to have. so you're not measuring out, save you a lot of time. Let's talk a little bit about programming the inverter, and we'll have a whole training coming up eventually here talking about programming the inverter for different use case scenarios. But a little bit about the front screen. So one of the real nice things about the Sol-Ark 15K is, yes, you can program it from the app, but you can also just use the buttons on the front of the screen. So you've got a number of things that are shown here in the front of the screen. You've got your DC solar shown here. You've got your grid and your export to grid or your input from grid. You've got your loads. You're sending out to loads at 5 kilowatts on the screen here, and your batteries are charging up. A negative on the battery means that battery's charging. And if you click here in the settings, if you click on the battery itself, it'll give you information on the battery. But if you click in the settings, you'll get into the setup mode. So there are a number of things to point out in the setup of the Sol-Ark inverter. Basic setup will give you things like screen timeout, but there's also an advanced tab in the basic setup that allows you to program a limit on your generator input. So you might have, if you've got a small portable generator, maybe a 5K generator that you want to try to integrate and back up the house with, or maybe even an 8K, you can limit the overall generator power draw in the basic setup advanced tab. You can also lock out the changes from the homeowner, so the homeowner can't screw anything up under the basic advanced tab. It's actually, there's a tab there called sorry, I'm blanking on the name here, system reset or factory reset, and that's where it allows you to lock out system changes. The default code for that is 7777. So if you're an installer trying to do that, and you haven't done it yet, the default code is 7777, and you can change that later, but that's where you would lock the homeowner out of system changes. We're going to go into battery setup. So under battery setup, you're going to have a number of different options here. If you're using one of our communicating batteries, you want to make sure to have a checkbox on the BMS lithium battery. The default address there is just 00 for Briggs batteries. Activate battery allows the inverter to start up the battery if the battery has kind of gone through a low battery cutout. You can use either a percentage of battery, so the state of charge of the battery, or you could use the battery voltage to adjust your settings within the Sol-Ark. If you have a communicating battery, we encourage you to use a battery percentage, and sometimes it'll default to that. Just keep in mind that some of the later settings are going to be grayed out if you choose a percentage versus a voltage. So for instance, I've chosen a voltage here, and on the right side of the screen, you can see the percentage is grayed out under the grid charge column here. Your overall battery capacity. So if you're doing parallel inverters, you would want to put the overall battery capacity in as the entire bank capacity. But under the amount of charge, if you've got paralleled inverters, it's per inverter, the amount of charging and discharging that you're getting. So keep that in mind if you've got paralleled inverters. Total bank capacity goes in here, max charge and discharge. You would want to put per inverter. Another thing to keep in mind about the max charge and discharge, this is the global limit. If you have communicating batteries, they might be sending a higher or lower charge. What the Sol-Ark uses is the lower of your setting and the battery setting. So battery has a maximum charge and discharge that it communicates directly to the inverter. And if that's above your limit, then it would use your limit here as the global limit. If it's below, then it would use the BMS's value. So that keeps your battery safe. The overall temperature coefficient for lithium batteries should be 0. They don't, their state of charge curve, their voltage versus state of charge curve doesn't change much with temperature. On the battery setup side here, so under charging, you've got options for charging from a generator. You've got options from charging from a grid. So you can charge that battery from, think of this as the gen port. So if you've got AC coupled solar, you could be charging from that AC coupled solar. So you can let it know what percentage, if you've got battery percentage checked here, to start charging. So this will start up your generator if you've got a generator connected here. And you can set it to charge from the grid, and say when the battery drops below a 30% state of charge, it'll start a charging cycle from the grid. Or if you've got the voltage box checked on the left, you could set the voltage at which you want it to start. Under the float and absorption, we float at 54 volts. We absorb up to 56 volts. So that does that constant current charging until the battery hits a 56 volts, and then it just does constant voltage. Equalization is there for lead acid batteries. It was to provide a high voltage for a short amount of time, about once a month. And what that would do is burn off some of the sulfur on the lead acid plates. We don't use that with lithium batteries. You always want to have this set to 0 hours, and that'll just prevent equalization. High voltage on lithium batteries can damage the cells, so it's important not to use that. If you check this generator force gen, that gen force will just automatically start the generator up. So if you're doing an installation, you want to make sure that, hey, I've got my 2-wire start wired properly, it's going to work. Click this, click OK, that'll start your generator up. Uncheck the box, click OK again, and that will stop the generator. One important thing to keep in mind, if you change settings in a Sol-Ark, you have to click OK. Think of that as the save button. Otherwise, it doesn't change your settings. Depending on what, on the discharge side of things, the low battery is just kind of the point, the percentage or the voltage at which the battery will start beeping at you. The inverter will start beeping at you to let you know, hey, you're getting low on battery. You can turn the beep off if you want, but that's just to trigger that signal that, hey, you're getting low on battery. So it'll send that to the app. That'll send you a notification. The shutdown voltage or percentage is a percentage at which it turns the loads port off. So if you're running off of solar, you don't have a generator, utilities down, it's nighttime, there's no more solar, the battery starts draining down. Once you get to 20%, it'll actually shut the loads off in the house. So keep in mind, if you want a lot of longevity with your batteries, you might want to be as high as 20%. But if you're only cycling your batteries occasionally, you can drop this all the way down to 0% and make full use of your batteries. I'll typically recommend a 10% or a 20%, depending on how often the batteries are cycled. If they're cycled daily, I recommend 20% because you get almost double the number of cycles. If you're only cycling, once every few days, then 10% is fine. If you're only cycling it during an outage, then just set this at 0%, and that allows a full discharge cycle to happen on the batteries. Even at 0%, 100% depth of discharge, you're still looking at thousands of cycles on these batteries. 365 cycles would be a year, right, if you did that daily. So battery resistance. So this is your bank resistance, and that goes down with a larger number of batteries you have. So the more batteries you have, the lower the bank resistance. I'm short on time, so I'm going to skip through this, but we have values. We can help you calculate that if you've got a question about it. It's 15 ohms per 6.6 batteries. So if you had multiple batteries, this would drop down. Basically, it's that 15 divided by the number of batteries. Under the grid setup, you've got a lot of control here. You're able to do things like limit how much power you overall sell back to the grid. You can also limit how much power that you pull from the grid. So if your loads are, say, 10 kilowatts, but you've set this limit to only 2,000 watts, then that other 8 kilowatts you'd pull out of the batteries or pull out of the solar. And you can also do time of use setup so that you discharge the batteries at a certain percentage as long as they're above that percentage during time of use. There are trainings on this, and so I'm going to skip through it. Under the grid input here, you can do, most common is 120/240 split phase for residential. But as I mentioned, you can easily set this up to do 208 two-phase if you've just got a single inverter. Or you could do a single phase that's 0 volts for your neutral and 240 volts for one of your live. You can also parallel these units, and this is where you would go into to parallel units. So if you're trying to do 3-phase Y configuration, you can set up each inverter should be a master on the phase A, phase B, phase C, etc. So just a few things about the My Sol-Ark app. So recently Sol-Ark upgraded to housing all of their data in the US on US based servers. They now own the software they used to use PV Pro. And so you can historically monitor batteries, loads, microinverters, the different power sources. So here's a nice example of a system running. It looks like they have microinverters connected through the grid port here. And you've got a nice example of those batteries charging up during the day and then slowly discharging at nighttime, reaching about 20% in the morning and then charging up again. Yes, Russ, I'm sorry. Next time I will definitely go in and change my mouse button. I know that my colleague Mike knows how to do it. I'm sorry I didn't get to that. Here's another example of microinverters that are being used. It looks like you've got a big load here, maybe the air conditioner turning on and off. And you can see those batteries are supplementing that solar power that's needed. So you've got microinverters more than the load most of the time. So this battery goes negative here, and the battery being negative means that you're charging the battery up. And then this customer has a time of use enabled, so it's not using those batteries at all from about 1 o'clock until 6 p.m. And then those batteries are kicking in to cover the loads later in the day, and you see the battery percentage drop off. All right, I am out of time. I'm going to skip through to the end here. One important thing to say is that the battery feeds a lot of information to the Sol-Ark, and you can see all of that through the My Sol-Ark app. So if you click on the battery information tab, it'll talk to you about the percentage of the batteries, etc., the state of charge. And so you can see a lot of information on your batteries. I'm going to skip my cold weather applications discussion here, but if you need heated battery cabinets, we can provide them. Here's an example of Sol-Arks and Briggs & Stratton batteries used at an installation in Buffalo, New York. We also have high voltage offerings. So we do have high voltage batteries that are made down in Oxnard. So if you're interested in powering the 30K and 60K Sol-Arks, we have integrations with those, and I'll be doing a talk on that soon. The SimpliPhi Elite Installer Program gets you $100 back per battery you install. So if you do a stack of 3 batteries for a customer, you get $100 back on each of those batteries. Let's suppose you do 5 of them in a quarter. We send you a check at the end of the quarter. So it's pretty easy to get that money back, and we process a rebate check quarterly to our IQ installers. If you have not installed one of our 6.6 ESSs yet, you can get $1,000 off your first 2 ESS purchases. So these batteries have been selling fast. We do have a little bit of a lead time right now on these batteries, but we should have a large inventory of batteries soon. The heaters are, yes, similar to pads, like on a generator heater. And in fact, they are pads, but they're integrated into the batteries, so they are a special order. And those pads it draws power. It draws about, I think it's 100 watts of power, but it's based on internal battery temperatures. So it's integrated right into the battery BMS. So great question. Thank you. So if you are looking for that NABCEP certificate, I apologize. I've kept you 3 minutes after the hour. I'm sorry for my technical difficulties on starting here. I had to switch computers last minute. But if you're looking for those NABCEP certificates, energy storage training at basco.com. And yes, they are connected with, I think it's a 2-plug connector on the top of the battery, and that's wired into the boss cabinets. So once more, NABCEP certificate, send me an email, energystoragetraining@basco.com, with how your name should appear on your certificate. It should match your registered name with NABCEP. So send me that email. I'll get your NABCEP certificates out to you by email today. Thank you, everybody. I appreciate your time here today. Sorry one more time for the difficulties at the beginning of this training. Glad we were able to get through. Thanks for joining us.